A magnetic moment provides the strength and direction for an object generating its own magnetic field. It has the symbol mu, which is just a different context than we had used it before. Mu is the magnetic moment. It's going to point in the same direction as the field that's created by a magnetic object. It's going to point away from the north of that magnet. All right, so I'm going to start with the simplest case here, a bar magnet. We want to just draw the magnetic field around the thing. So as we saw when we first started magnetism, there's going to be loops of magnetic lines. They point from north to south. That's what we saw in the past. But the thing that's new is we're also going to draw the magnetic moment vector, mu. And what it is, it points away from the north of the object. Okay, it's mu. Magnetic moment. And it turns out to be a very useful vector when it comes to finding out what a magnet is going to do when it's in another magnetic field, as we'll see. A compass needle is nothing more than just a magnet. Okay, so it's going to have its own field lines. All right. And even a compass needle will have a magnetic moment as well. We've seen that when a coil carries a current, then it can have a magnetic moment too, because it will have a magnetic field going through that coil. Now, if you remember, we had to use the right-hand rule in order to determine what direction the field will be going in this coil. So if this is the positive side of a DC battery, then current is going to flow this way. It'll flow up through the coil and come out the other side. So using the right-hand rule on that, I find that the magnetic field actually flows in from the left side and it'll come out the right side. Okay. Now, there will be loops just like there were above. Okay. And so the magnetic moment that's created by this coil will point to the right, which means that this side of the coil is like the north of a magnet, and the other side would be a south. Here's one more loop. We can see that the current here is going counterclockwise. And I want to show you just a new way of finding the direction of a magnetic moment. You can actually use the right-hand corkscrew rule to find it. Here's how it works. You imagine putting your fist like up against the loop. So take your right hand, curl your fingers in this way, and then when you do, your thumb is going to point this way. Now what we're doing is we're curling our fingers in the direction that current is going this time. So that's something different. Okay, so current is going counterclockwise in this loop. So we want our fingers to go counterclockwise as well. See that? So the fingers are the current this time. So what's the thumb? The magnetic moment, mu. So that's just a little bit different way we can use the right hand to quickly find the direction of the magnetic moment. And notice that it's also going to be the direction of the field as well. See, this loop creates a field that's going to come out of the loop. All right, that means that the right side of the loop is a south pole, and the left side must be a north. Okay. All right, so that's magnetic moment.